So hello guys, welcome to my YouTube channel Data Stories. In the previous lecture, we have studied linear regression practical part, right? So in today's lecture, we are going to start new algorithm of supervised, that is logistic. Logistic regression comes under the classification algorithm. Okay, so before proceeding, I want to suggest you that please watch my previous lecture as it will help you to gain the knowledge and also write down the notes that I am giving to you. These are the most important notes as it will help you in your interview. Okay, with that, let's proceed. So we are going to learn today logistic regression. So regression, logistic regression. So it is an supervised machine learning algorithm. So what is supervised machine learning algorithm? As you already know that supervised means that target variable is present and sampling is possible. So it it is an supervised machine learning algorithm. Okay. So in this case, the target variable is always binary, 0 or 1, or true or false. In linear regression, the target variable was real and continuous. You note the difference here in logistic regression, the target variable is only binary. Target variable is always binary, that is in the form of yes, no, or 0 or 1. Okay, so in logistic regression, we use confusion matrix. So what is confusion matrix? I will explain you just after a few minutes. So in logistic regression, we use confusion matrix. So why confusion matrix is used? Confusion matrix is used in any of the classification supervised learning, right? So confusion matrix will be used to evaluate the logistic regression model. As we have learned in the linear regression, some evaluation parameter like RMSE, MSE, right? So in logistic regression, that is a classification algorithm, we will evaluate the parameter with the help of confusion matrix. First, we have to plot the confusion matrix. Then we have to judge it. Like, is the confusion matrix well? Is it well? Then sit further. And if it is not well, like if the problem is of oversampling, undersampling, we have to deal with it. Don't worry, I will teach you oversampling and undersampling in my next few videos. So that's it. So now we will learn about confusion matrix. So evaluation, evaluation matrix used for evaluating the classification algorithm, that is confusion matrix. We use confusion matrix for this. Okay, I will write down here confusion matrix. Just leave a line here so that you will get it clearly. Okay, so now I will show you an image. Just look at it. So this is the actual diagram of confusion matrix. In the x-axis, there is a predicted values, and in the y-axis, there are actual values, right? So what is this TN, FP, FN, and TP? I will tell you it afterwards. First of all, please note down this diagram of confusion matrix. Okay, I hope you have noted down this confusion matrix. Now I will explain you the confusion matrix. Let me open paint window. Okay, here just I have drawn the confusion matrix. Here in the y-axis, there is actual values 0 and 1. And in the x-axis, there are predicted values 0 and 1. These are the random values that I have taken 22, 36, 14, and 47. Okay, so wait a minute, I will open a brush. Okay, so I will redraw it once again. Okay, these are the actual. Okay, as you know that these are the actual and these are the predicted. I will not write again. So I will write here 0, 1, 0, 1. In actual, the class is 0. Okay, we got some value. And in predicted also we got the class 0 value. Right? It means true, right? So I will write down here true. So in actual we got 0, class 0. And in predicted we got class 1. So it is false. So I will write down here false. Same goes here. In actual we got class 1. And in predicted we got class 0. So I will write here false. And in actual predicted both are 1. So true. Just draw this diagram right here actual and right here predicted. Okay, so hope you have drawn this diagram. Now I will give you some of the important points. Okay, so class 0 will also be called as class negative. Okay, we are seeing in predicted case. So it is called negative. Okay, so and class 1 will also be called as class P. Okay, this class N is class negative and class P is positive. Okay, so class 0 will be called as class negative. I will open my paint window once again. So class 0, we have to see the predicted case. So class 0 will be called as negative. So I can write here as N, right? Here also I can write N. Okay, okay. And class 1 is called as what I have written here. Class 1 will be called as class positive. So this will be FP, right? And this will be TP. Just adjust the diagram. This is TN This is FP, Hope you get my point. So what is this TN, that I have written? TN is true negative, FN is false negative, FP is false positive, and TP is true positive. So what are these? So first, true negative. So true negative is that the number of correctly predicted negative cases. As I've explained you that 0 means true. So for the in actual we got true and in predicted we also got true. So true negative. So true negative is number of correctly predicted negative cases. False negative. I've explained you that 1 and 0, it means false. So the number of incorrectly predicted negative cases. These are not true. Okay. So And FP means false positive, the number of incorrectly predicted positive cases. And last one, true positive, the number of correctly predicted positive cases. By the analogy I have explained you before, you can relate this term very easily. So for you, I will write it down here. You also write it in your notebook. So what is TN? TN is true negative, the number of correctly predicted negative cases. These are instances where the model correctly predict the negative cases. So what is Fn? Fn is false negative, the number of incorrectly predicted negative cases. Okay, and now FP is false positive, the number of incorrectly predicted positive cases. By the term, you can understand what is it meaning. Okay, so true negative. True means it will be true, and negative the number of correctly predicted negative cases. False negative, false means something is false. So number of incorrectly predicted negative cases. So false positive, something is false. The number of incorrectly predicted positive cases. Okay, now the last one. You may comment down what is the meaning of last one in the comment section. I will wait for a minute. I hope you have commented down the meaning of this. So it is number of correctly predicted positive cases as it is true. The number of correctly predicted positive cases. Okay, so these are some terms related to the confusion matrix. Okay, so the evaluation parameter we are going to see in the next video. So now we will continue further in confusion matrix. Okay, now I have tell you there are the y is the target variable, like so y can take only two values, that is 0 and 1, and the most important point, and it will work on principle of probabilities. Okay, so in linear regression there was not any such kind of term that is probability. So here we are dealing with probability, like whichever probability is more of class 1 or class 0, the final assumption will be in that class. Okay, so for example, here is class 0. Okay, here we got something like 45.2, and in class 1 we got 50. The final prediction will be in class 1 by this analogy. Okay, hope you are getting the point. Okay, So now, what is the probability of odds? Probabilities of odd. That is, P plus Q equal should always be equal to 1. Means that P is the class 0 value and class 1 value is Q. So the addition will always be equal to 1. If it is not, then there is a problem in your model. You have to check it. So these are the values that I have assumed. So don't add it and write down in comment section that you are teaching us wrong thing. These are just the random values I have taken. For example, okay, so what is the probabilities of odd? Is that P plus Q should always be equal to 1. Okay, and whichever probability is more, the final prediction will be in that class only. Okay, so whichever probability is more, the final prediction will be in that class only. The final prediction will be in that class only. Okay, so the S curve or sigmoid curve we are using to see the probabilities. So in which class the probabilities will be there. If the value is smaller than zero point 0.5, then it will be in class 0. If it is greater than zero point 0.5, it will be in class 1. Okay, so sigmoid curve, or it is also called as curve, is used to differentiate the probabilities. Okay, so differentiate the probabilities. So I hope you are getting the concept. I will show you how the sigmoid curve look. Just let me open the paint window. Okay, so sigmoid curve. Sigmoid curve is like this is y. This is one line, and this is one. Okay, so it is 0.5. 0.5. It is class 0. If it is less than 0.5, then class 0. And if it is greater than 0.5, then it is class 1. Okay. This was all about the logistic regression that I have explained you. In the next lecture, we are going to study the evaluation parameters of logistic regression. I hope you understand the concept. If you are enjoying my lecture, then please like it and do subscribe my channel, as it will give me the motivation to bring more such videos. And yes, the confusion metric topic is quite difficult to understand. And if you find it easy from my video, share it. Okay, so thank you for watching my videos, and I will see you next time.